So if I could ask people to, okay. Welcome everybody. I think we'll get started now. It's that's 3 minutes. I've got the agenda. Oh, I'm Mike Morrow. I'm the president of the St. John Center of the RESC. Most of you know that. We're going to do things in a little bit different order. Our speaker tonight, Dr. Neish, we're going to let her get away. We're not going to hold her up too long. She's in a different time zone and has some other responsibilities in the evening. But I will do our acknowledgement. We acknowledge that the lands on which members of the St. John Center of the RESC live and pursue our hobby are situated in the traditional territories of diverse Indigenous groups, and we acknowledge with respect the diverse histories and cultures of the Beothuk, Mi'kmaq, Innu, and Inuit of this province. So with no further ado, I'm going to introduce our speaker. It's Dr. Catherine Neish. She's very generously agreed to give us a talk. She's at Western, and you've seen the title, Dragonfly, a rotorcraft lander at Titan. Dr. Neish is an associate professor of earth sciences at Western. She uses orbital radar observations to study the geology of planetary surfaces, particular focus on processes related to impact cratering. She's involved in several spacecraft missions, serving as a co-investigator on NASA's Lunar Reconnaissance Orbiter Mini RF instrument and NASA's Dragonfly mission, which is what we're going to hear about tonight. And you'll have to pay attention because we won't be including this talk in the recording of this meeting. So you're going to have to pick it up the first time through. So with that, I'm going to stop sharing and I'm going to ask Dr. Neish to start sharing, and then we'll have to just make sure that everybody can see what. Okay, so we'll go back to our regular schedule now. So I'll do some announcements now. The RESC annual general meeting, you should have the members should have heard something about that. It's Sunday, right? And you do have to register. It's pretty easy. Just go to the RESC site, AM-2025. You get the Zoom link for that, and it's probably good for people to go and find out what's going on. Coming up in the summer, and I'm going to say a little bit more about it in a few minutes, we've got the Butterpot Star Party at the beginning of August, and I'll say some more about what goes on there. The Terra Nova Night National Park Night Sky Celebration, August 22nd, 23rd. And then our next meeting, we don't meet in July and August, will be September 17th. And that'll be our, we'll sort of go through what's happened in the summer and wrap things up and then proceed from there. So that's what's coming up. Most people here are members, but just to remind you, the meetings are open to everybody. You don't have to be a member, but there are benefits to membership, including access to our RESC NL Talk channel and lots of mentorship and discussion there, some journals, free planetarium shows. There's a weekly and a monthly bulletin. And with that, go away. I will go away eventually. Just review some of the things that have happened since the last meeting. Many of you were at the event on June 3rd at the Geo Center. It was the update reveal for the Our Future in Space display. So that was something that Kate Murphy and Andrea at the Geo Center applied for money, and we helped them a little bit. There was a question and answer session with part of it is highlighting researchers from Memorial. So Dr. Nielsen, Ivan Booth, and Penny Morrill. And then Dr. Susan Redmond gave a talk about balloon-borne telescopes. And amazingly, the moon actually came out. It didn't look like it was going to happen, but it did. So we had some viewing outside the moon. It was still pretty light at 9 o'clock, but the moon was what we could see. So that was one event that we had a couple weeks ago. And now we get to, drum roll, please. There we are. The results of the AstroImaging contest. We have some plaques. We have some gift cards for winners in the three categories: landscape, solar system, and deep sky. And they're from the Hibernia Development Management Corporation. And thanks to Jim for scaring those up. And then we have a plaque for the overall winner, and that has a gift certificate from Ontario Telescope. So we had some sponsorship, and we also have gift certificates for honorable mentions. And so, with no further ado, so what happened? If things were posted, people voted, and so thank you for voting. There we are. So the winner for the landscape was Greg Baggs. You want to come up? And maybe somebody could take a picture as I hand this to Greg. Here he comes.
For that one. Yeah, that was a test shot I took one night. I was out to Witless Bay Line to try to take a photo of the comet. I decided to focus on the moon in the opposite direction while I was waiting for it dark enough. So I was looking for something to throw in for a landscape, and I saw that, and I took a little crop, and that's it.
Okay, so face the camera there.
All right.
Okay. Our next category was solar system, and it's the sun. Bernard Day. Is Bernard online? I don't know if I saw him. Okay, that's too bad. Okay, well, we will have to somehow get that to him. And the next one, who's this guy? Jim Johnson. So this amazing shot of dark nebula. And it was interesting the way the voting worked, because depending on how people made their choices, the overall winner didn't have to be one of the three that we've just seen. And in fact, this time around, that was the case. So the overall favorite was Bernard Day with the witch head, which we had all seen, and is also a very amazing picture. And so we'll have to figure out how to get the stuff to Bernard.
I'll send it to him.
Yep. And then we had some honorable mentions. So for landscape, John Peddle, and I don't think, is John online? I don't think I saw him either. Okay, so that has a another gift certificate, and don't want to give anything away, so here we are. That one, that's what this certificates look like. And thank you, Randy, for framing those. And for solar system, Chris Stevenson, come on down. Might as well pass opposition. That's certainly very deserving. And Bernard also gets an honorable mention for this for the deep sky. That's, I don't think, do we have a certificate for him? I don't think we did for him, right?
Yeah, back.
He got plaque, so he's taken care of. And for the overall favorite, come on down again, Greg. So I think that was a fairly successful contest. Thanks everybody for that entered, and thanks everybody that voted. Oh, hang on. There was one more honorable mention, but this one had already gotten a plaque. So, you know, for completeness, I'm mentioning the ones that were honorable mentions. I think Jim had the other honorable mention. So for future entrants, you may want to think about vote splitting. Anyways, so thanks again, everybody, and congratulations to all the winners. So summer plans, what's planned so far is we've got 3 events planned. One of them is a sort of private event for the children at Camp Delight, which is a camp for children that have been affected by cancer. They aren't necessarily children that have cancer, could be children with siblings who had cancer. And Doug and Robert are going there on July 17th. And it won't be very dark, and there won't be much up in the sky, but Robert can show them some pictures and Doug can tell them some stuff about the solar system. And then our annual Butterpot Star Parties, August 1st and 2nd. So that'll be public observing on Friday and Saturday evening, and some solar viewing on Saturday afternoon, and maybe a barbecue or something. Yeah, a barbecue.
Barbecue, yes.
Yeah, it's been pretty thin the last couple of years and coming out of the pandemic. So
We may also have a law and order to dipper ceremony if anyone.
whatever that is, yeah.
It's a telescope, you know?
Right. And then later in August, the Terra Nova National Park Night Sky Celebration. We've been doing that for a number of years. We helped them get their dark sky certification, and so we've continued to cooperate with that. We'll be looking for some volunteers to go out there. August 22nd and 23rd. 24th is sort of that's the Sunday, that's kind of a rain date for the solar viewing. So in the evening, the events are at the activity center in whichever loop that loop A thing, loop A. And so there's some crafts in the activity center, some presentation, some stuff probably talk about light pollution, and we'll just put out a display table, and then afterwards, as it's starting to get dark, we'll do some observing just outside the activity center, so it's not the darkest part of the park, but it's probably the most accessible part. And then Saturday, we go to the visitor center, so up the road at Salton's Key, and do solar viewing there. The bird watchers were very disappointed when they came by one year and they thought we were looking at a Stellar's eagle, but we were looking at the sun. And so they all stomped off. So that'll be Saturday afternoon. And then Saturday evening, we'll go to the sort of official dark sky part of the park, which is Sandy Pond, and see whatever we can see there. And that's usually pretty good. Last year, the weather wasn't our friend, but I think last year was really the only time I can remember in the last several years that we've run into trouble.
I think it's free park entrance and camping fee we got this year, right?
Yes, yeah.
Oh, for everybody.
Yeah. They're encouraging people to park.
Okay. And then Sunday morning before we pack up and go, whoever's still around, we might do another hour or two of solar viewing just to sort of round things out again back at the visitor center. So that's what we've got planned right now for the summer. And so as we get closer, we'll probably be sending out a call to find out who's available to help out. And we will need some help with Terra Nova because it's a bit of a long drive, and we don't have quite as many people making it out as we used to, but still it's a nice weekend. Okay, so observations. Remarkably, it wasn't looking good at the beginning of the month, but we did end up getting some images. So we didn't get any solar images this month. We certainly could have, but I think people were concentrating on other things. But we had a lot of the moons that were submitted had the word hazy in the title. So this one from Jim, May 29th. So and you can actually you can't see it as well. I can see it on the screen. There's a little bit of earth shine there. You can actually see the rest of the moon in there. And then Randy, a couple weeks ago, nice shot of the moon with the sea star. And this actually the same night, John Peddle also with the sea star. So there you are. And then June 10th, the famous strawberry moon, which had nothing to do with the fact that it was that color. It's because it's strawberry picking season, but it's not strawberry picking. Why do they call it strawberry moon?
That's ours.
But
Wild strawberries were available this time here.
yeah, not here.
Back in Ontario.
Okay, yeah. Okay. And but Randy did some shots. There was a lot of smoke around that time, and so everything was quite red. You all remember that, but it made it very hard to see anything except the moon. And this famous picture from Jim made it onto Here and Now, and was also in their weekly roundup of photographs. So I saw it on there. Lovely shot there, very nicely composed. Everything going for it, and a star. And I included a couple scenic shots here. Greg did one of the Milky Way, just using, I guess, where's Greg? That just handheld, or no? He must have it on tripod. Oh, of course, because it's many exposures. Yeah. So
No tracking.
no tracking.
Where was that from? Alpro? The Dragonfly.
Yep, and it has been pointed out online. It's Mount Pearl because you can see the ghost of the sprung greenhouse.
Used to be able to work on my car at midnight.
We live in the east end of St. John's and we could,
Yeah.
we could see it from the east end of St. John's. So. And Gary's daughter in Denver also did a Milky Way shot, so I threw that one in too. And so now some deep sky objects. So the first one I've got is just to orient you here. Here's Cygnus and Hercules, so M13 is up here, and Cepheus, and this is NGC 7023 or C4, the Iris Nebula. It's a reflection nebula, so it's got small dust particles that are scattering blue light. Not that far away. I'll remind you, the galaxy, our galaxy, is 100,000 light years across. So that means this is pretty close to us. And there it is from Jim Stacy using his 800 millimeter lens on a Poseidon C camera. Lots of exposure, so that's just a beautiful shot. Lot going on there. So thanks, Jim. And so again, here is Cygnus, and so here's the summer triangle, Vega, Deneb, and Altair. And in here is the Dumbbell Nebula, so it's a planetary nebula. So I've mentioned this before. Stars up to about 8 solar masses, when they get to the end of their life, they've used up all the hydrogen in the core. They've burned helium in the core, used that up, and then there's just the outer layers start to when they become red giants and they're fusing helium to make carbon, nitrogen, oxygen. They swell up. That's what a red giant is. The outer surface gets very cool, and eventually the outer surface escapes, and that's a planetary nebula. It's got nothing to do with planets, but it's just, you can see the outer layers escaping from the star. The core is left behind. It's still hot, and that becomes a white dwarf. And so here's a shot from him and Sue in Sue's observatory, the Dumbbell Nebula, and I guess that's probably going to be the white dwarf right there. Lovely shot. That's a lot of detail for the Dumbbell Nebula. Very nice. And M56 is a globular cluster in Lyra. So there's Lyra. So again, here's the summer triangle. So as we get into the summer, a lot of things are going to be in this neighborhood. So again, the globular clusters got the Milky Way. The globular clusters are sort of distributed kind of spherically around Milky Way. Is that a good way to say it?
Yeah.
More or less. Yeah. So remember, the Milky Way is 100,000 light years across, and this one's 33,000 light years away. So sort of out of the plane of the Milky Way galaxy, but still involved. Lots of stars in it. Now, when I looked it up, so I'm just a question for Chris. The estimated age that I found on Wikipedia is, I was a little puzzled about that because that's pretty close to the age of the universe.
For a
So
long time, globular cluster ages, which were determined through stellar astrophysics, and nucleus synthetic processes and so on, and their metallicity, were constraints on the age of the universe because they were so close to, right? Well, the universe can't be, globular clusters can't be older than the universe, right? So sometimes they came right up against the fence. That might be an older reference.
yeah. Anyways, I put it in. The main thing is a lot of globular clusters are very, very old. They're very old stars.
Probably only like 13.5. Yeah.
Could be, yeah. So
Well. 12 billion years old.
yeah. So here's Chris's shot of M56. They look pretty old to me.
The
talking about globulars, because Sue and I looked at some globulars at the also. The other night we saw M12, M10, M3, and 13. Only 10 had quite a few stars in it, but it was quite faint.
Yep.
One final note on globulars. I keep forgetting myself, someone else here was looking at things in Sagittarius, which I can't see from our yard because of the trees that have grown up around my telescope. So Sagittarius is up in my backyard. So I was like, what? How many busy objects are there in objects in Sagittarius, which is looking towards the center of our galaxy? And I keep forgetting, like there are half a dozen or 8 or 9 or 10 globular clusters in Sagittarius alone. So that's so yeah, if you think you only see globulars when you're looking away from the center of the galaxy.
Okay, well, that's useful information, yeah.
You have to use both the reducers at the same time, or is that?
Oh, it was a numbskull experiment. I probably just worsened the image quality slightly with all the optical surfaces, and you don't use reducers like that. So anyway.
Yeah, so I put it in for completeness, but it's discussed in detail in Chris's post. And then we had a lot of action with the Ring Nebula, which is also a planetary nebula, 2,500 light years away. And again, you can see if in some pictures you can see the core. It's been expanding for about 1,600 years, and planetary nebulas have a finite lifetime, a few thousand years maybe. So here's one from Tim and Sue, and just sort of barely make out something there in the center. But
Central stars is relatively.
yeah, it's a very photogenic object, but very small. So, and here's one from Jim, and I can see the white dwarf in there, and one from Chris, and one from Jim. So many people represented in the looking at the Ring Nebula. And this is Jim's antique telescope, right? The Maxitov 4-inch. And then again, we're getting into summer, so all the action, a lot of the actions in around the summer triangle, so in around Cygnus. The Pelican Nebula is here. There's a lot of nebulosity in this region, a lot of gas and some star forming regions. So in the Pelican Nebula has ionized hydrogen about 1,800 light years away, and there are some star forming regions in here. And NGC 6823, that's an open cluster with some nebulosity, still some gas around it. Further away, 6,000 light years, but still on the scale of the galaxy, not that far away. And the center of this cluster, open clusters tend to be very young stars that haven't gotten away from each other. So you tend to get some very bright blue young stars, which the very bright, hot blue stars burn out in only a few million years. Our sun's going to take 10 billion years to use up the hydrogen in its core. The very hot, bright blue stars use up their hydrogen in millions of years. So these are actually only millions of years old. So the Pelican Nebula, first of all, and I've looked at this one a few times, Robert, and I'm not sure which way the Pelican's facing. Right?
I don't see his beak is pointing out.
Beak is pointing. Oh, yeah, okay, I see it. Okay, yeah. Yeah, but very lovely colors in that. Yeah.
Like the bottom is like the back of his head.
Okay, yeah. So the pouch is there. Is that?
Yeah.
Okay.
Very sharp.
Yeah, very nice.
That's the dark.
And this is that open cluster. So these are the very hot, bright stars, and this is presumably some of the interstellar medium that they condensed out of. And then we've got the Tulip Nebula, a Sharpless and an H2 emission nebula, but Chris, I think this, you were saying this was more
I hope that's not mine.
afraid so,
That was a dismal failure.
but that's okay. This was more like a test shot, right? So,
Yeah, this is a demonstration of, yeah, if you're going to go after hydrogen emission from a well-lit suburban backyard, use narrowband filters. Especially if the moon is out.
okay, well, you see, that's worthwhile showing it just to
Yeah.
get that, so we'll just go through it quickly. It's there, but it's
Yeah.
very hard to see.
There's a black-ish, darkish arm going up towards the middle star from the bottom left. And that in nice photographs, that's a
Oh, that one there?
opaque dust feature and so on and so forth.
That's kind of what it would look like visually, anyway, wouldn't it?
Yeah.
Yeah.
And, M16 and M17, so now we're getting down towards Sagittarius. There's lots of neat stuff down here. M17 is the Omega Nebula, also called the Swan Nebula. So it's an ionized hydrogen region. There is a star formation region, and it's illuminated by an open cluster. So again, bright stars, few 5,000-6,000 light years away. And the Eagle Nebula, so the Omega Nebula is down here, the Eagle Nebula is up here. And again, a region of active star formation. It's famous for the pillars of creation, about the same kind of distance away. So there is the Omega Nebula, and Omega, for those of you who haven't spent time doing Greek letters, Omega is the one that looks like this, right? And so I believe it's sort of here, and here's the loop like that. I think that's what makes it Omega. And what makes it a swan is the same thing. If you sort of turn it on its side, there's the swan in the head. I don't know, something like that. Anyways, another nice shot with the 9.25 inch telescope in Sue's.
That's one point out there was those images were made with 5 stack.
Yes, yeah, thanks for pointing that out. That's one of the things that's interesting here is that Tim was using Sharp Cap, but just letting it stack, because you aren't actually tracking, are you?
It's actually live, Sharp Cap actually tracks the image itself.
So it sort of,
Yeah, it locks on.
yeah, so it
actually locks onto the stars and
yeah,
and tracks the image.
but the telescope itself is not tracking, so
The
that's
telescope would be tracking with the mount,
Well, it's aligning and stacking.
Yeah, like the telescope is still tracking with the mount, but there's a slight error in the.
oh, okay, so because I was thinking that you had a star sense, but you do have a track.
Yeah.
Yeah.
Yeah, so it is tracking on a mount, but
Okay.
I'm saying there's a slight drift there, so.
Okay, very good. Anyways,
Actually locks onto the stars and corrects the drift error.
Image stabilization.
Yep, very good. Okay.
Almost like auto-binding, it's kind of almost like auto-binding.
Okay, very good.
And so you don't need to store any images, it all stacks in real time.
Okay, very good.
8 minutes, that was only it.
Yep, so very nice shot, and not very long.
And same with the dumbbell, was done that same way as well.
Yep, okay. And then a little bit further down, this is starting to get kind of low for anybody who's got trees. But the Trifid Nebula is very colorful. Another ionized hydrogen region, about 4,100 light years away. And so here's one from Randy. Now, oh, actually, yeah, I was going to put this one. I thought I'd moved this one. Anyways, we're going to hear something about, you see, framing demo. Randy's going to tell us something about that in a minute. And maybe this picture should have gone with that, but, and this was also with 90% moon. So we'll find out what this framing means in a second. And then, I think this is from Jim. This from you? A wide angle shot with the Red Cat 51 or 50? 50. Of the Trifid Nebula and the Lagoon Nebula. So we just saw the Trifid Nebula, the Lagoon Nebula is another emission nebula. Roughly the same, 4,000 to 6,000 light years away. And there it is, another beautiful wide angle shot. So that's Trifid and that's Lagoon, right?
I was taking was 50 millimeter, I remember, based on much resolution.
Yeah.
Zoom into it, there's a lot of.
Yeah, there's a lot of stuff there. That's a fairly big file too, right?
That image there. No, not really.
Okay.
Focal ratio on the red cat, Jim.
5.75.
Well, it's-
That's
all
fine.
that.
The petrol, 400 elements.
Yes.
I just mentioned that because I noticed that storing my set of slides always gets just a little bit slower when once I add one of these. So
Send you the small one back.
anyways, another beautiful shot, just so much stuff going on there.
Link to that image went around in the email. The image itself was not included. Stupid.
Okay, and we had some shots of M13, and so the Great Cluster in Hercules. So again, a globular cluster, 22,000 light years away. Mostly older stars, but there are, and Chris likes to refer to blue stragglers. So they're old stars because these are stars that have, sometimes these globular clusters might have been a dwarf galaxy that got disrupted or failed or something like that, got somehow entrained with the Milky Way galaxy. But they tend to be old stars that have been, they're gravitationally bound with thousands of stars. And there aren't any young stars because young stars, as I was saying, they go for a few million years. So you end up, what you can see as old stars, except that sometimes the old stars can run into each other and kind of reignite, and you end up with a hot new star, and those are the blue stragglers. Is that a reasonable thing to say?
It's basically ball of old suns, and very occasionally you get a merger and a more massive star burns hotter.
Yep. And so Jim did a lovely shot of M13. You can see some of the colors of, these are probably stars that are a little bit, they're still associated with M13, but maybe a little bit closer to us. I had a try at that. And then I also tried the Sunflower Galaxy. So this is the Big Dipper. There's M81, M82 we're familiar with. M101, M51, the Whirlpool Galaxy, and then the Sunflower Galaxy's down here. And so there's a couple nights. And I've been sort of struggling because I can't last past midnight. So I'm doing this while it's still pretty, between 10 and 12, and it's not very dark. And I'm also trying to get used to a new computer that has a monitor with kind of weird colors. But anyways, I was pretty happy with that. So that's 2 nights, a couple hours of stuff. And M3, another globular cluster, again, about 33,000, 34,000 light years away. So to orient you, there's the Big Dipper, there's Arcturus, Arc to Arcturus, Leo, and M3 is in here. And there's Jim Johnson did that one. And again, lots of detail in there. And this also 9.25 inch telescope. But only 110 minutes, so that's pretty good. And then in the Cygnus region, and we've already looked at the Summer Triangle. And I think what we're going to look at now is the North American Nebula. And this is, I think, where I'm going to invite Randy to come down and tell us what's going on here. So this is Is this a new feature on the Sea Star?
So, we've had a couple of major updates to C-Star this year. One was to add what they call framing or mosaic node. The other was to give us equatorial node. Equatorial just means you point it up like you would an equatorial mount. But it also unlocks a number of other features. Tracking is much better. So they allow you to go much longer exposures. Instead of 10 seconds, you can go to 60 seconds now. But I think you're going to have to be in a portal 0 or 1 to get 60 seconds. Anyhow, just a couple of framing shots here. This is all done by the atlas that comes with the Sea Star. You click on the atlas, pick your object, frame it up. One of the shortcomings supposedly of Sea Star is that it has a portrait mode sensor. So it's a small oblong square. So things like Andromeda, you can't capture all of Andromeda. So a bit of sleight of hand, what they've done, you can unlock what they call framing, and by magic will do all this sort of stuff. So you've got your square of what the object is. That opens up another panel which has
I'll point where Randy's pointing on the screen.
you'll have both magnification and also this wiggle thing here allows you to actually seemingly to turn the sensor, but you're not actually turning the sensor. It will also then give you an estimate of how long you're going to need to shoot that object, right? So this is just a framing shot. Do you got some other framing shots for me?
Yeah. So, is it like if it's too big, does it sort of do like a little mosaic?
At the very last picture, it does them around and stuff. It takes you much longer to get the image that you think you're getting. And
Okay, so,
but again,
so
that's only a 2-minute shot. Okay, and 90% moon. I did a 2x stretch just to get that much.
so that's the Omega.
Mhm.
Okay, and there actually you can see the swan there.
Yeah.
Upside down. And then here's the eagle.
Again, I stopped this one deliberately after just a couple of minutes, just to see that the whole image hasn't been imaged yet, just enough to see that it was starting to form. And that again is a 2x stretch. I did try any with the rotating the sensor. I'll next time we go to Butterpot, I'll do that. Is that the last of mine?
Yeah, I think so.
Okay.
Yep, and okay, well, thanks for all your contributions
All
and
we need now is a better sensor on the feedback.
okay. And Robert, did you want to do the sky this month? Or do you want me to just run through it? Okay. Okay, well, the main thing about the sky this month is that it's not very dark. That's the challenge right now, and there's the reason. There is some activity on the sun, so we didn't get people put away their solar scopes this month, but there were probably opportunities. So there was apparently a big flare, yeah, last night, or so maybe we're going to be getting some action there. The planets, you can see when they all set. They're all setting in the afternoon, or except for Pluto. So Pluto's there for you if you want.
It's not fun.
Right, you're right, but we'll give it a pass there. The moon's 20 days old, so the moon's rising at midnight now, right?
Yeah.
So there you are. The comets that I mentioned to Robert that the headings seem to be a bit messed up here, but that's the magnitude, that's the constellation, that's the separation from the sun, that's the notes. And but yeah, there's nothing there that really sort of leaps out at you right now. Asteroids, there's always a few around.
I've been doing best a lot.
Yeah, okay. And Robert, again, has given us a list of objects either with binoculars or deep sky, and they're some of the ones we've talked about. M101 near the Big Dipper, M5 we just saw. Where's M102? I should know that one, but I don't. Anyways, some of these I don't know. And I guess T Corona Borealis hasn't happened yet, right?
No, I haven't checked the last minute.
Okay. But we are sort of, we're actually getting back into T Corona Borealis season, right?
Yeah.
So we can start watching it again, but so for people who weren't here a year ago, this is a star that's supposed to go nova. So it's not a supernova, but it's a star that's accreting stuff, I guess there's a partner, right? And it's supposed to get enough stuff that it will brighten up, and that will be a nova, and it does it periodically every 80 years or so. And people expected it to happen last year, and we watched it until it became hard to see over the winter, and now it's coming back into the sky, and it still hasn't happened. So it'll be quite exciting when it happens. It will still only be about as bright as Polaris, I guess.
Which
So
is, well,
it's pretty bright.
it's the closest repeating, kind of close but variable. And certainly the brightest. All the others are telescopic objects, even when they're at maximum, like this one's as bright as Polaris.
Yeah, so it'll be a big deal when it happens. So
1944, I think the last time, it was back when there wasn't much light pollution and lots of people could tell, oh, look, there's a new star in the sky.
Yep.
We hope people pay attention at all this year, but there's a cadre of keeners.
okay, and the next meteor shower, I guess, is coming up in July, but the big one's going to be in August, Perseids, or one of the big ones. Okay, I'll probably leave it at that. Space station.
I noticed Robert also put in the Abell 2065, which is one of those nice distant galaxy clusters with lensing. So that's a challenge indeed.
Okay. And you can find that on the website it's actually under outreach. And so, just to remind you, we've got the general meeting coming up on Sunday. Hopefully some people will attend online. You do have to register in advance. We got the couple events coming up in the summer. Randy.
First, got a comment.
Oh, let's see. Southern Hemisphere observers got one already, Naked Eye Nova. I didn't know about that. Marcellus, do you want to come on and say something about that, or not? Maybe not. Anybody know about that? Okay. Thanks, Marcellus. We'll watch for that. And okay, take a look in space weather. Okay, and our next meeting is in September. So with that, oh, it's all gone.
Not even any icebergs.
Anyways, there was our show. So thank you all for coming. Have a good summer. Be safe. Hopefully you can get out and see something. And that's it.
Thanks.